We've got some interesting stuff going on here. I have a 6-digit integer. It looks like a binary because I want to treat it as such. Remember, in Python, the number types are integer and float. And of course, while behind the scenes, it is dealt with as binary. To make our lives easier, Python does not show us the binary format numbers by default. So I'm going to show you how I can take an integer, play around with it in binary format to make our binary concept stronger bit by bit. They say that if you can say the numbers from 1 to 100 and 100 to 1 backwards as a child, it is a sign of mastery. So we'll be doing the same thing, but with binary numbers in line with that idea. What does the reversed integer look like? It is exactly as you would expect, as shown by the output here. As with any problem in programming, there is an easy way, the direct way, or the brute force way, and the hard way, which is the not so direct way. The easy way is like this. Since my integer is not going to be shown to me as a binary by default, I typecast the number into a string, which I can format to be shown as a binary. The number is now in a string format, which I then typecast into a list. This breaks up the single string into individual ones and zeros. Then I call an inbuilt function called reverse, which, as the name suggests, reverses everything in the list. Now I typecast it back into a string so that it stays in its binary format. Then I typecast a string into an integer. In code, this means I'm completely using inbuilt functions and the internal concepts of Python to achieve this reversal. The key takeaways from this exercise should be that this 0 small b keyword allows me, the user, to see an integer as a binary number, and the 06b while converting to string. By default, Python removes the leading zeros of a binary number, so I need to specify this 06b when I'm converting to a string to say that this is a 6-bit binary, and to put the 2 leading zeros or how many ever zeros accordingly. Run this code for yourself with different values of the integer and then replicate it without looking at the solution. Now the hard way and what you've been waiting for. I need 2 major concepts here, and I hope you remember our shifting and masking. Initially, our output is 0 and our left shift power is 5. Why 5? It is because we have a 6-bit number, so the last position is going to be position 5. Let's see what we are doing with this shift first. I have 4 main steps here. I'm taking the LSB, or the least significant bit, from my binary number, then I'm shifting it 5 times to the 5th position of the output, which was initially 0. What do you think I'm doing this for? Did you notice any changes from the last slide? One would be that our number looks a little different than last time. What I'm doing here is I'm building up the output bit by bit using the LSB of the binary number, which is written as an integer. And after I've taken the LSB, I do not need it anymore, so I push it out the right side using a right shift, and that's right shift by 1, where it now becomes a ghost and we stop caring about it. The left shift has changed from a 5 to a 4 to 3. It is because for each LSB I'm stealing from the original number, it is being added to positions on the right side of the output. Once again, I'm taking what's in front of the original number and then pushing it towards the back, so I'm reversing the original number 1 bit at a time. After that, I right shift by 1 again, and I push out the LSB I don't need anymore. Notice here that my original number after right shifting by 1 becomes all zeros, which means that I have used up all the bits and my reversed output is now ready. I told you that I'll be using a mask too, and I've used it. Where do you think it is? I've used the mask to essentially check a bit, as we looked at in lecture 9, and to ensure that I can get 1 LSB at a time, and this is what I move to the right side of the output. How can I make sure that the output gets built up properly and does not get overwritten? I add the output, which was shifted, let's say 5 times in the first case, to an output, which was shifted 4 times in the second time, and keeps going to get me the reversed output, which we all know and love now. As you notice some obvious repetitions in the process, you should be thinking that I need to use another concept to make this algorithm more smoother and not code this bit by bit process manually. We use loops to make the code repeat. This is less intuitive than our easy solution, but it is doing these things in order. You're checking the bit at position 0 or LSB at my integer, then you're shifting it by a certain value to the right side of the output, and then you add it to the existing output. You shift my integer to the left to get rid of the LSB, you reduce the left shift value by 1, and you repeat this until my integer is all zeros. Take a look at it and see how you can solve it.